We only have about 2.5 hours to do this, right? We do have a formula sheet, yes. Let's check out what the formula sheet has in it. It has a couple of volumes, circumference, the length of an arc of a circle, area of a trapezium, the roots of a quadratic equation. So it have your quadratic here. It have the SOHCAHTOA over here. Oh, SOHCAHTOA is there, boy. I didn't even realize they have SOHCAHTOA. Right? Area of a triangle, right? Herod's formula and other formulas here for the area of a triangle. The sine rule, the cosine rule, which we'll need for the bearings questions, right? So those two are things that we'll need, especially this area, the sine area thing, we might need that. Now, of course, you can use your calculator here, right? So in terms of using your calculator have this button in it. So if you wanted to punch this entire thing in your calculator, you would have to type 4, press the button, 1, press the button, 5. And on your screen you would see 4, 1, 5. So that is 4 1/5 as a mixed number. Then you actually press the multiplication sign, right? And then you press the third, so 1, you press the button, 3, and you'll get 1, 3. And let me actually do that on my calculator now. 4, 1, 5 multiply by 1, 3. And the answer I got, they're showing me here, I have 1, 2, 5. So this is a mixed number, 1 2/5. And so 1 2/5 now are going to minus. So I'm pressing the minus sign, and I'm pressing 1, the button, 1, the button, 4. So that's 1 1/4. Right, so 1, button, 1, the button, 4. And the answer that I got here is 3 20, yeah?
Yeah.
Alright. Now, did you know this way to do it in terms of the calculator?
Yeah.
Alright, good. So I'm just making sure, because a lot of people didn't know it. And in terms of this one, 4.1 minus, on the calculator, I would actually use brackets here. And I would press the x squared button there, just to get those brackets there. And I would actually work that first. So 4.1 minus, open brackets, 1.25 squared, close brackets. I would actually press enter here to give me 2.5375, and then I would press divided by 0.005, 0.005, and we get 507.5. Nice?
Yeah.
Right. Now, I was actually working on some of these questions from before. So we have here, a stadium currently has a seating capacity of 15,400. Calculate the number of people in the stadium when 75% of the seats are occupied. So 75 of 15,400. Zap, zap. So that gives us 75 multiplied by 154 is about 11,550. That's a lot of people, right? And then they were saying here, and I was actually doing some of these questions with another class, so I'll erase all of that. They were saying here that we now have 2790. We used to have 15, how much was it? 400. So when I minus that, was the difference? 2790 minus 15,400. So that gives us 5390. So this is the amount that we added. So we had 15,400 and we add in the 5390 to get the 20, right? So the thing is that a lot of students make this mistake. What percentage increase in the number of seats? Remember, we had this amount of seats before, and we want to know what is the percentage increase from this number. So this number doesn't really have anything to do with it. This number just helps us to find the difference. But we want the percentage increase from that number. So we find the fraction of that number. And some of my other students before found the fraction over this number. And we multiply by 100 over 1. And I do believe the answer is 35%. We got 35 for this?
Yeah.
All right, lovely. Yeah. Nice. Right, and this one was actually pretty easy. I don't have to erase this one. A neon light flashes 5 times every 10 seconds. Right? Show that the light flashes 43,200 times in one day. So I want to find out, well, how many seconds are there in a day? There are 60 seconds in 1 minute, multiply by 60 minutes in 1 hour. Multiply by 24 hours in one day. So we have 86,400 seconds in a day. And now we say, well, all right, the neon light flashes a certain amount of times every 10 seconds. So I'm going to take the amount of seconds in a day and divide it by 10 to find out how many 10-second segments there are. And there are 8640 10-second segments in a day. And in each 10-second segment, the light flashes 5 times. So times 5 gets you this. Were you okay with this one?
No.
Oh, okay. So yeah, but do you understand what was the mistake that you made, and do you understand what I did here? Do you need me to explain?
It's not really tied up. So I understand what you did.
You sure?
Yeah.
Alright, got tied up with what?
I found how many seconds was in an hour, and then I kind of didn't know what to do from there.
Right. So you found how many seconds in 1 hour, right? So you have 60 seconds in 1 minute, right? But then you have 60 minutes in 1 hour, right? So I take the amount of seconds. So I have 60 seconds in a minute, right? But I have 60 minutes in an hour. So I multiply the 60 seconds by every one of them minutes, right? So 60 seconds in 1 minute times 60 minutes in 1 hour. That gives me the amount of seconds in 1 hour. And then I have to take that amount of seconds and multiply by 24 because there are 24 hours in a day. So that gives me the amount of seconds in 1 day. Alright? So you're okay with this right now?
Yeah.
Alright, lovely. If you're not okay with it, feel free to say so. Alright. So as I say, this paper 2, I'm just going to breeze through the solutions for this, right? Factorize the following expression completely. Well, I have to look at what is common. Now, when they say factorize, I'd like you to always remember, factorize means that you are finding the factors of something. So if I have the number 6, I could factorize the number 6 and break it up into its factors, 2 and 3. So what I did was I broke it up into its factors, and when I multiplied these factors, I will get back the number 6. So that is what factorizing means, right? Is that you're finding the factors, the two things that you can multiply to get back this, right? So at the end of the day, what I will do is I will take a look at each thing, each number here, and I will see what do they have in common. Well, 5 and 12 don't have anything in common, but they both have h in common. So if I was to pull out h, open brackets, 5h minus 12g, right, close brackets, you'll see that I now have two numbers. I have this number in the brackets and this number outside the brackets. And if I multiply, I will get 5h squared, and h times this is 12hg. So this here is the answer for a simple 1 mark, right? When it comes to factorizing quadratics, we see that a is not 1. A is greater than 1. So when a is greater than 1, it have a different method that we use, right? We have to find two numbers that when you add them, you will get this middle number here, which is minus 1. But when you multiply them, you will get a times c, which is 2 times negative 6, which is negative 12. So two numbers that when I add them, I'll get minus 1, and when I multiply them, I'll get negative 12. Well, those numbers are negative 4 and 3. So negative 4 plus 3 is negative 1, and negative 4 times 3 is negative 12. And if you're having problems figuring out what this is, just think about this. Check this first, because it's easy to find the factors of 12. The factors of 12 being two numbers that you have to multiply to get 12. It's easy. You have 1 and 12, you have 6 and 2, you have 4 and 3. Yeah? And then once you find that, once it works with this one, then you know you have it. Right? So we see here that the two numbers are negative 4 and positive 3. So what I'll do is I'll take those two numbers and I'll use it to replace this middle number over here. So I now have 2x squared, and I'll replace that middle number with minus 4x plus 3x. You see that middle number, minus 4x plus 3x, it just gives us this. So it's pretty much the same thing, and I have the minus 6 on this side. Right? And now what I'll do is I'll factorize each side. So I'll factorize this side and I'll factorize this side. But I'll factorize this side first because it doesn't have any square in it. So if I pull the 3 out, you can see that I have x minus 2 in the brackets. Right? So 3 times x is 3x, 3 times negative 2 is negative 6. And so what I'll need to do is put the x minus 2 over here as well. Right? And of course the plus sign remains here because it was positive 3. Right? And when I got this x minus 2, I have to have it on this side too. So I put the x minus 2 there, and then I ask myself, well, what do I have to multiply by x minus 2 to get this? And the answer is 2x. So 2x times x is 2x squared, and 2x times negative 2 is minus 4x. And so now I see I have my two factors here, x minus 2 and 2x plus 3. So factorizing a quadratic, imagine all of this was 2 marks. So you have half mark here, half mark here, and maybe another half mark here, and I don't know how they separate 2 marks, but half mark for all of this stuff. So generally each step in a paper 2, you can expect to get a half a mark for it, right? Which is why all of the steps are important in terms of, you see how I did it, right? I basically wrote it down like a story. You could tell the steps that I take, and then I came across here, and you could tell what I did with each line. You could tell what I did, right? So you want to do that. You don't just want to have working all over the place. Now this is a simple equation here. And the first thing we need to do is to open out these brackets. So I'll have r plus 3. Notice the next line. From here, the next line must make sense. So from r plus 3, I didn't touch this side, but on this side I'll have 3r minus 15. So you could tell that from here to here, all I did was expanded the brackets. Now what I'll do is I'll throw this r over on this side, and I'll throw the negative 15 over on this side. So it'll become positive 15 plus 3, and this 3r, and this r over on this side will become minus r. So now I have 18 is equal to 2r, therefore r is equal to 9. Notice the steps. You could tell what I did from one line to the next line. It makes it easy to do, right? So what we have here is we have to make k the subject of the formula. So what I will do is I will flip the entire thing. Pi k squared plus 3t is equal to 2a, right? So I could take the 3t and throw it across first. So pi k squared is equal to 2a minus 3t, right? Now k squared is equal to 2a minus 3t all over pi, and therefore k is going to be the square root 2a minus 3t all over pi. And if you don't put the brackets, that's fine, no problem. Right? So Scotia, you get through with this one?
Yeah.
Alright, lovely, right? A farmer plants 2 crops, potatoes and corn, on a 10-hectare piece of land. The number of hectares of corn planted is C. So let me start to write down the information they're given there, right? So corn is going to be C. The number of hectares of corn, C, must be at least twice the number of hectares of potatoes. So potatoes is P. And the number of hectares, that's not, a farmer plants 2 crops, potatoes and corn, on a 10-hectare piece of land, right? So when he plants the potatoes and corns, the amount of potatoes that he plants plus the amount of corn that he plants has to be either less than or equal to 10. So that is one equation. You can't be planting more than 10 hectares of land. So how much ever potato he plant and how much ever corn he plant, right? It has to be equal to 10 hectares or less than 10 hectares, right? So that is one, because they want 2 inequalities. So the other inequality comes from the number of hectares of corn planted. So the number of corn must be at least twice the number of hectares of potatoes. So corn must be at least, when I say that I have to have, that me, that are like Shazay has to have at least twice the amount of money as Scotia. At least twice the amount of money as Scotia. That means that Shazay must always have more money than Scotia. Yeah? And this is the language here. If Shazay has to have at least twice the number of money as Scotia, right? So if Scotia have $5, right? Shazay must have at least, for the least, he could have twice that number. So for the least, Shazay have to have 10. Yeah. So at the end of the day, he cannot have less. At least that means that he could have more. So the amount of corn has to be greater than or equal to 2 times the amount of potato. Yeah, because the amount of corn must be at least, so it can't be less, because at least is the bottom of the barrel. Yeah, it can't be less, it have to be more, right? So these are the 2 inequalities that we come up with here. How did you guys do with this one? Yeah or nay?
Nee.
All right, but you guys understand what I did with the at least thing?
Yes. Yeah.
All right, nice. Okay, so did you guys get at least one of them?
I got something close to it.
What you did see is that.
No, I had 2C
2C, all right.
and then P.
But did you have 2C, this, and then P?
Yeah.
Right. So imagine now what you're seeing here is if you had $5, right? Because remember, I could throw this 2 across, and it's going to be C is P divided by 2. So if you had $5, right, then how much Shazay will have? Shazay will have $2.50, and 2.5 is not greater than 5, right? At least you had the correct sign though. But you understand how I worked it out, how I reasoned it, right?
Yeah.
All right, nice. And don't worry about getting things wrong, because I do expect you guys to get this first couple of past papers to make grave mistakes, and that is okay. So we can see here I did this one previously with another class. So the answers here are, the diagram below shows a hexagonal prism. The prism has 8 faces, 18 edges, and 12 vertices. Anybody have any arguments with this?
Yes, sir.
Alright, so Coach, you got this, right?
Yeah.
Alright, lovely. Now, a sports club owns a field PQRS, right, in the shape of a quadrilateral, right? A scale diagram of the field is shown below. 1 centimeter represents 10 meters. Alright, so we could actually measure it because they say it's drawn to scale, right? The following show all of your construction lines. So this is a construction question here. And what will I do is, the field is to be divided with a fence from P to the side RS so that different sports can be played. So a fence from P to the side RS. Now, they never said, and this is one thing I have a problem with in this question, right? They never said if this line should be perpendicular to RS. I don't think they ever said that. Use a straight edge and a compass only and construct the line representing the fence. They never said that it should be perpendicular. So you could have constructed that line, or you could have constructed this line, or you could have constructed this line, because all of those lines starting at P and cutting RS, right? So they never said anything about how it needs to be perpendicular to RS. And in terms of the construction, using a straight edge and a compass only, construct a line to represent the fence. In terms of the construction, it's just 1 mark. So because it's just 1 mark and they did not use the word perpendicular at all, so I don't need to worry about this being perpendicular. It's just 1 mark anyway, right? So what am I going to do to construct a line? I could put the compass here, right? The point of the compass here, and draw an arc so that it'll cut here. Then put the point of the compass here and draw another arc so that it cuts back at P, and then use the straight edge ruler and draw my line. And that should definitely be, so you're basically constructing a line. And that should basically be enough, especially if they wanted it perpendicular. It would have been a lot more than just 1 mark, right? And write down the length of this fence in meters. Well, I don't have a ruler. I can't quite measure it. I don't know if I can I? Do I have a ruler here? Tools. Draw. Audio translate. No, I don't have a ruler here. So let's just say I measured it. And let's just say I got... Anybody measured this? What did you get?
I got 6.9 meters.
No, how much centimeters? You got 6.9 centimeters.
Yeah.
Right. So if you got 6.9 centimeters, 1 centimeter represents 10 meters. Read your question carefully, right? So they ask you write down in meters. So if you got 6.9 centimeters, 1 centimeter represents 10 meters. So multiply by 10 will give you 69 meters. You understand?
Yeah.
All right, nice. So that was 1 mark. So I think that your lesson that you have to learn, Scotia, is to take your time and read and look out for certain words, and every single word is supposed to be important, right? We have here a translation, the quadrilateral PQRS, and its image, we can see it's some sort of an enlargement here. Write down the mathematical name for the quadrilateral PQRS. Well, that is a trapezium. A trapezium is some sort of a parallelogram, right? PQRS is mapped onto the image by an enlargement with a scale factor K about the center CAB. Using the diagram, determine the values of A, B, and K. Using the diagram, determine the values of A, B, and K. Well, I could find the scale factor K pretty easy. I could see here that this side is 1 unit, and this side is 3 units. So this is 1 unit, and this is 3 units. So how do I go from 1 to 3? Well, I have to multiply by 3. I could see it here again, 1 unit, 3 units, 2 units. So if it works, I should have 6 units here, and yes, I do. So obviously we could see here that to get from one to the other, I have to multiply by 3, and so the scale factor K is equal to 3. Now to find AB, and I'm not too sure if I could, oh yes, I think I can draw straight lines here, but I might get it wrong because my straight lines aren't really that great. Just now, how do I get a straight line? Edit, insert, shape, line. Nice. So what I need to do is take this Q here, and I need to connect it to that Q there and extend it. Right? And I hope that that is it. And then what I do is I could take, just now, insert, come on, shape line, right? And I could take the point P if I want to, and I could extend it to touch the other point P and then keep it going. And I don't particularly need to do the rest there. I don't need to do the rest. 2 of them should be enough, right? Because you could see that they intersect at this point over here. And if I was to connect R to R, it would intersect in the same point there, and S to S would intersect. So this is the point C, the center of enlargement. And we can see that this point 1, 2, 3, this is -4. And on the y-axis 1, this is 1 on the y-axis. So the point C is actually -4, 1. So therefore A is -4 and B is +1. Any questions? Okay. Ooh, algebra, my favorite, right? So we have this function f of x, and we have to find the value of the f of 4 plus the f of -4. And please look at how I write my statements, right? The f of 4, and I'm being a gentleman about it, implies, right, that I have 2 into 4 plus 7 divided by 5, which is 4 2s are 8 plus 7 divided by 5, which is 15 divided by 5, which is 3, right? And then I have the f of -4, and I'm going to implies 2 -4, right? And sorry for my scrappy handwriting, but I just want to show you the steps that I'm taking. This is -4. because these steps is what makes it easy for the examiner to mark you, right? Plus 7, make statements over 5, right? So this ends up being 4 2s are negative 8 plus 7 over 5, which gives you negative 1/5, right? Negative 8 plus 7 is negative 1, so I have negative 1/5. So therefore, the f of 4, notice the statements, plus the f of negative 4 equals or implies 3, you notice I write the 3 under the f of 4, plus minus 1/5, which is 3 minus 1 on 5 is 2 and 4 on 5. Right, so I can move on there, right?
Yes, sir.
Okay. You got through with this one?
Yeah.
Alright, lovely. Lovely, right? Calculate the value of x for which f of x is equal to 9. What it is? 2x plus 7 over 5, right? So f of x is equal to 2x plus 7 over 5. Making these statements is not just for the examiner, it is also for you to have all of the information here. You don't have to keep going back, right? So if f of x equals to 9 implies that 2x plus 7 all over 5 is equal to 9, right? Therefore, 2x plus 7 is equal to 9 times 5. 5 9s are 45, right? 9 times 5, yeah? 45. Right? Therefore, 2x is equal to 45 minus 7 is 38. Right? And x is equal to 38 divided by 2, which is 90. Nice? Remember, I could make mistakes too, eh? So please let me know if anything looks off. But I think everything is pretty good there. Right? Hence or otherwise determine the value of f inverse of 9. Hence or otherwise. The f inverse of 9. And how much marks we have? 1 mark. Right? I mean, we could go through all of the things for 1 mark, but let me see. Let's just see what happens if we find the f inverse, right? So if f of x, and remember to find f inverse, we'll just call it y, and I'll just do it quick. Y is equal to 2x plus 7 all over 5, right? Remember, in order to find the inverse, the first thing you have to do is make x the subject of the formula. So that's pretty much what we did in the last question there. 2x plus 7 is equal to 5y. 2x is equal to 5y minus 7. X is equal to 5y minus 7 divided by 2. And therefore you switch the x and the y. So y is equal to 5x minus 7 divided by 2. And what happens if we put 9 in here? 9 minus 7 divided by 2. What will we get? We will get 9, 5 9s are 45, minus 7 divided by 2. Which is the same 19. So the point here, I determine hence or otherwise, and you notice it's just 1 mark, right? The point here is, look at what we did when we found the inverse. Right? We actually made x the subject of the formula. We find for x. Yeah? But look at what we did here. Right? We basically, instead of we basically found for x and we put the 9 where the y is. And we put the 9 where the y is. Right? And look at over here, what we basically did was we put the 9 where the y is, f of x is, you know, so where y is, that is where we put the 9, and then we substitute not substitute, sorry, we made x the subject of the formula and got 19. So that is why it's 1 mark, because what we actually did here was we actually found the inverse of the function by making x the subject of the formula, which is what we did here. So you could have just put 19 if you'd like, but I wanted to show you why 19 is correct, because finding the inverse is pretty much the same as what we did here. Any questions?
No.
All right. Shazay, you surviving?
Yes,
Somewhat, okay. The graph below shows two straight lines, L1 and L2. L1 intercepts the x-axis, I could see that, at 4, 0 here. And 0, 2. Wait, L1 intercepts the x and y axis at 4, 0. What? This is bad English. Oh, the x and y axis, the 4, 0 and 0, 2. Yeah? And respectively, okay? And L2 intercepts the x and y axis at 1.50. So we can see L2 here, 1.50. And 0, -3. So this is where those points are, respectively, right? So that is great that they gave us this, because remember, they're basically given us 2 points that are on each line. And with 2 points, I could find the equation of the line. I could find the gradient of the line. I could find all sorts of things. Determine the equation of L1. Well, you know the equation of L1. Let's write down the points. L1 implies, what are the 2 points for L1? 4, 0 and 0, 2, right? So I have 4, 0 and I have 0, 2. Nice. And now I will say, recall y is equal to mx plus c, right? Implies that m is equal to y2 minus y1 all over x2 minus x1. So I could go ahead and find for m. Let's take this as the x2, y2. So y2, which is 2, minus y1, which is 0, all over x2, which is 0, minus x1, which is 4. And that gives me 2 all over -4, which is did I do something wrong here? -1/2. This is for L1. Oh yes. And L1 here, we see that this is L1. And we can see here that L1 does have a negative gradient. I mixed up L1 and L2 for a minute there. I was watching this line. So you could tell if you got it correct by visually looking at the line, okay, that's a negative gradient. So therefore, y is equal to x plus c. And now it's to find c. C is the intercept on the y-axis, and we can see here that c is 2. Yeah. Now, if we wanted to, we could have used any one of the points, right? And let's use this point here when x is 0. If x is 0, we could see that c is going to end up being y, which is 2, right? So you could see there, you could put that from the graph, or you could use one of your points to work it out, no problem. Right? You could put the point in here, or you could say from the graph c is equal to 2, that's the y-intercept. Therefore, L1 implies y is equal to -1/2 x plus 2. Look at all of the statements, please. And I know it's scrappy, so don't take the scrappiness as an example, right? But just look at the statements. Recall y is equal to mx plus c, because the examiner don't want you to just write this just so. The examiner don't just want you to jump to this just so. No, They want to see that you know this. They want to see that you know this, right? So this is how I do everything. Not only that, but writing all of these statements means that you have all of your information, in front of you, and you're less likely to make a mistake, right? So I make statements like this, or if I use the point, I would actually write using the point, and then I would show the algebra for it, you know. So make proper statements, right? What is the gradient of the line L2 given that they are perpendicular? Well, that is actually easy, and we can see it's just 1 mark for that, right? So L1, the gradient m is -1/2. Right? I want the gradient for L2, and I know that L1 is perpendicular to L2. That implies that if I take their gradients and I multiply the gradients, I am supposed to get -1. So therefore the gradient for L1 is -1/2 multiplied by the gradient for L2, and I am supposed to get -1. So therefore M2 is equal to +2. So the gradient here, +2 times -1/2, will give me -1. And you can see there that we got a positive gradient. And we can see here that the gradient of L2 is indeed positive. Nice. Any questions on the coordinate geometry? No?
No.
Okay. Statistics. A group of 100 students estimated the mass m grams of a seed. So I'm guessing a group of 100 students estimated the mass of a seed. So I'm guessing that they guessed the mass of a seed. And I could see here that out of 100 students, 20 students guessed that the seed was below 2 grams. Yeah, I could see here that 50 students guessed that it was below 3.5 grams, right? So that is what the cumulative frequency curve gives us. Yeah? Using the cumulative frequency curve, estimate the median. So just remember, the mode is the most popular, the mean is the average, the median is the one in the middle, and it's quite easy here for 1 mark. We know that we're going from 0 to 100, so the median is the one in the middle, so that'll be 50. All we need to do is cut across here and come down here, and what we'll see is 3.2 grams is the median. So the answer there is 3.2. And yes, you can actually draw on the question paper, and please draw on your question paper. Please feel free to do working on the question paper. You are handing up the question paper as well, right? So actually this here, you're doing all your working on this paper, and you will be given scrap paper if you ask for it. And if you're given scrap paper, you'll want to hand up that too, right? The upper quartile and the semi-interquartile range. Well, we know that if we have a bunch of data, right? Like, let me just say I have, all right, well, look, I have a bunch of data here, right? 0 to 11. So it's 10. Okay, wow, thank you very much. So you see, I can make mistakes too, right? So in that case, the range is 1 to 10. So if it's 1 to 10, and now we'll get to see it being an even number, but you're absolutely right there. I'm sorry, let me see if it printed correctly. Yeah, it is. It does look like it stops there. Yeah, so if it stops there, then the range is actually 0 to 10. Very, very good, Scotia. Thank you very much. So since the range is 0 to 10, right, then we have an even number, right? So therefore, Q2 is going to be here. Q2 is going to be 5.5. Right? And so you can see that if this Q2 is 5.5, then we have this side here, which will end up being an odd number. So we could see that Q3 is actually 8. And then this side here, we could see that Q1 is actually 3. Right? So I could go, so it's really 8 minus 3. Yes, thank you very much. Because Q2 there is 5.5. So, you know, the mistake I made had a small little error in it. So Q3 is really 8. Thank you very much, Scotia. And you see how deadly that is. Hey, Scotia read the question correctly and I read the question wrong. Look at that. Yay, Scotia. Good job. All right. Yeah. So it'll actually be Q3 being 8. Sorry, Q3 being 8 and Q1 remains 3. Right? Q1 remains 3. And so we'll end up getting now 8 minus 3 is what? 5. So 5 on 2, which is 2.5. 2 2s are 4 1. Yeah. So the interquartile range is about 2.5. That is the distance from here to here, which is the interquartile range. But then you're dividing that by 2 to get your semi-interquartile range, right? The number of students whose estimate is 2.8 grams or less. Wow, that's really, really crazy. Okay, yeah. Yeah, I have to zoom in a lot. Okay. All right, I'll accept 38. Yeah, it definitely looks like 40 there at a glance. Sorry, guys. You see, that is the mistakes that you just make when you're rushing it down and you're trying to do it in under 2 hours. Yeah. So take all your time. Right? So yes, 38. Good job. Thanks again, Scotia. Right. The cumulative frequency curve on page 18 to complete the frequency table below. Right. Somebody want to fill this out for me? Because I don't have the graph in front of me. The frequency is the amount of students, right? So the amount of students that said that you have, and look at it, right? The amount of students that said that you have between 0 and 2 grams is 20. So if we look here, right? Between 0 and 2 grams, we're seeing that 20 students there said that. Right? Let me just erase all of this. So we could see that. And now let's look at this underneath one here. Between 8 to 10 grams, one student said that. So let's see how that makes sense, right? Between 8 to 10 grams, we could see it goes from, well, they count that as 1. So I guess that is 99 because yes, this here will be 98. Right? 90, 92, 94, 96, 98. So therefore, that's about a halfway through. So that would be 99 to 100. So one student from 99 to 100 said that it's between that range there. Right? So how many students said it's between 2 and 4? And thank you for making me go up and down, up and down. So from 2 here to 4 here, how many students is that who said? So it goes from 20 to 70. So that is 70 minus 20, which is 50, right? So we have 50 students here. Between 4 and 6. Between 4 and 6, it goes from 70 and 6 here. And since they want to be so exact, right, that is 92, 93. That is 93 over here, right? So 70 students minus, no, 93 students minus 70. (93 minus 70), that gives us 23. And well, the rest of it is already filled out there for us. Right? A student is chosen at random. Find the probability that the student estimated the mass to be greater than 6 grams. So how many students thought the mass was greater than 6 grams? Well, if I look at it here, 6 grams, that is 93 students. So from 93 to 100, right? 100 minus 93, what is that? 7. So 7 students thought that this thing was greater than 6 grams. So it's only 7 out of the full 100 students. So what is the probability that a student chosen at random, that you will get a student who thought it was more than 6 grams? Well, only 7 students thought it was more than 6 grams over the entire 100 students that were reviewed. So the answer is you have a probability of 0.007. No, 2.07. Sorry. 0.07. 2, yes. Nice, so we have some geometry now. Question 6 is now 7 o'clock. I hope that I can finish this before 8, but we'll see how it goes. The radius of each circle in the triangle, blah, 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 below is 7 centimeters. So I can see this line here from here to here is 7. Right? The circle fits exactly. So if from here to here is 7, 1, 2, 3, 4, 5, 6, 7, 8. So 7 times 8, that is 56. Yes, I did use my calculator to do that. 7 8s are 56, right? So we can see that this here is 56 centimeters long, and 1, 2, 3, 4, 5, 6. 7 6s are 42. So this is 42 centimeters long. Okay, you notice I didn't read the question yet. I just using the information to work out things and make sense of things. Show that the area of the rectangle is that. Well, the area of the rectangle will be 56 times 42. So the area of rectangle is equal to 56 times 42, which is, which is 2352, right? The problem is a full 2 marks, right? So what you need to do is we need to put more work in. So let's just put, the length is 7 times 8. 7 times 8, which is 56. Width is 7 times 6, which is 42. Therefore, the area, we just want to make sure that we get the full 2 marks, right, of the rectangle is equal to 56 times 42, which is 2352 squared. Calculate the area of the shaded region, taking pi to be that. So how many circles do we have in all? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 circles in all. So the area of one circle is pi r squared, which is 22 over 7 times 7 squared. Well, of course, this will cancel here. That is why they said to do that. So 7 7s are 49, so that's 22 over 7 into 49. And well, 7 into 49 will give you 7. Okay, so 49 divided by 7 is 7. So now we'll end up with 22 times 7, which is 154. Right? So the area of one circle is 154 centimeters squared. Right? So therefore, area of 12 circles is 154 times 12, which gives us 1848. Right? Now the area of the shaded region equals the area of the rectangle minus the area of the circles. Right? So that is the area of the rectangle we got here to be 2352. I keep putting the comma in the wrong place, damn it. 2352 minus 1848. 2352 minus 1848. 504. 504 centimeters squared. Okay. The diagram below, not drawn to scale, shows a triangle MNP in which the angle MPN is equal to the angle PMN, and MN is 12.5. I can't believe that they actually did it. But anyways, right? So we have all of the information here. We saw that these two angles, and remember, if these two angles are equal, you can think about them like the base of an isosceles, where this is 52 and this is 52. So that means that these two sides are going to be equal. Yeah? So that means that if this is 12.5, then this is also going to be 12.5 centimeters, because this would be an isosceles triangle, right? So state the type of triangle shown. Isosceles. I hate this to spell isosceles. I just feel I get it wrong every time. Did I get it wrong? Is that correct? I think this C, maybe no. Ollie, help me now. How do I spell isosceles? I think it's that. You know what? I'm gonna Google it. I forget how to spell isosceles. Yeah. ISOS. Yes, I knew that. ISOS. I knew it had a S and a C there, right? ISOSCLES. Yes, I know it had an S and a C somewhere in there, right? So, Scotia, you could not help me to spell isosceles. Scotia, Shazay, you all there?
Yeah.
All right. So, calculate the value of this angle PNM. Well, we know that inside of a triangle is 180 degrees. So the value would be 180 degrees minus the 52 plus 52. So 52 plus 52 is 104. So that's 180 minus 104, which is 180 minus 104 is 76. Right? Calculate the area of the triangle MNP. How did we do that? The area of the triangle MNP. Anybody?
1/2 AD sin C.
Thank you. Right. So the area. So we could use. I mean, you could do different things. You could have cut the isosceles so to make a right angle triangle. But then you would have had to find the length of this side, and you would have had to use sine and cos and thing. But no, it's 1/2 AB sine C, where C is this angle. We will use this angle here to be 76. And AB will be the two sides on either side of that angle, right? So that means that we have 1/2 A, which is 12.5. Is it 12.5? B, which is 12.5. Sine of C, which is 76. Shazay, you worked this out?
Yes, sir.
How much you got?
75.8 centimeters squared.
with these exact numbers, right?
Yes, sir.
All right, so 12.5 times 12.5 times the sine of 76 equals to that divided by 2, 75.8. Good job. All right, now this here is the topic that I didn't do with you guys. We actually only looked at it briefly, and I did post that 20-minute video teaching it. It's actually quite an easy topic, right? The sequence of figures is made up of stars using dots and sticks of different lengths, so I could see that the first 3 figures in the sequence are shown below. Study the pattern of numbers in each row of the table below and show each row relates to a figure in the sequence. Some rows have not been included in the table. So we can see here, this is figure 1, figure 2, figure 3. Let's look at figure 1. In the first figure 1, we have 12 sticks all together. All right, and we have 13 dots, okay? And then we can see here that it goes up from there. Figure 2, figure 3, they actually gave you for figure 4, right? And we have to find the nth term. Now I did do a full video on this, and it's just 20 minutes. So see if you could go and check that out. So the nth term, so let's take the number of 6. This is 2 different sequences that we have to handle there. So let's look at this first sequence, the number of sticks, right? So the sequence itself goes 12, 24, 36, 48. It looks very familiar, doesn't it, right? Dot, 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 yeah? And of course, the nth term is 1. This is the second term. This is your third term. This is the fourth term. Dot, dot, dot. This will be the nth term here. So what do I want to do? And we'll follow the steps that I have in the video. And if you watch the video, it's just 20 minutes. You'll see I do the same steps. The first thing I want to do is write down the nth term here. 1, 2, 3, 4. Right, and n, because I know that I'm going to need that n in order to get this, right? So how do I take, what do I have to do to n in order to get the sequence? Well, the first one I have to multiply by 12 to get that. Then the second one I have to multiply by 12 to get 24. 12 3s are 36, 12 4s are 48. So we can see here that 12n will actually be the answer for the number of sticks, right? And you want to work out your nth term first. If you work out the nth term, then you can get to find everything else, right? So next now we have the sequence 13. Oh, this one looks a bit harder. 25, 37, 49, dot, dot, dot. Yeah. And what I will do is I'll do the same thing. The nth term is first, this is the second, this is the third, this is the fourth, dot, 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 and the nth term here. So I am going to put the n here, and I'm going to ask myself, well, what do I need to do to n in order to get 13? Well, I multiply it by 13, right? 13 times 2 is 26 minus 1. But the thing is, I had a minus 1 here too, so this is not correct, but I'm trying things right now. Let's just try 13 times 3, right? 13 times 3 is equal to 39 minus 2. Well, look at that. right? 13 times 4, and I'm gonna guess here by saying I'll have to minus 3 over here. So let me see. 13 times 4 is equal to 52 minus 3. Yes, it's 49. So you see, what I did was I put the n there, and then I asked myself, what do I need to do to the n to get this? You can see this first one here is minus 0, right? So you can see a clear pattern going on here. That I have 13 being multiplied by n, and I'm going to minus. What am I going to minus? Well, you notice that the number that I'm minusing is always 1 less than n. So whatever n is, the number that I'm minusing is 1 less than it. So I'm minusing n minus 1. So whatever n is, I'm minusing 1 less than it. Whatever n is, I am minusing 1 less than n. Right? So now we end up having 13n minus n plus 1. Right? Which will actually give us 12n plus 1. So now you can see here that this is the sequence that I get, and let's see if that sequence is actually working. Right? Even though I used 13 and I got some different mad thing, I was able to work out algebra and get a final sequence here. So let's see if 12n plus 1 actually works here, right? So n is 1, so if I take 1 multiplied by 12, I'll get 12 plus 1 is 13, yes. 12 times 2 is 24 plus 1, yes. 12 times 3 is 36 plus 1, yes. 12 times 4 is 48 plus 1. So even though my thinking was a little bit off, I just used some logic here. I tried, you see the mistake that I made was I tried multiplying by 13 first. Yeah? And maybe if I had tried multiplying by 12 first, then I would have gotten this right one time. But I tried multiplying by 13 first, and so I got something that was a little more complicated, but I was able to use algebra to still find the answer, right? So the answer here is 12n plus 1. And I do suggest that you guys take a look at that video. It really is just 20 minutes. And one of these questions does come in every paper too. So you really want to check that out, right? So now that I have these formulas, I can actually figure out everything else. Right? So figuring out everything else now, what am I going to get? Well, 156 divided by if 12n is equal to 156, then n is 156 divided by 12. 156 divided by 12 is 13. So over here is 13, right? And then over here now will be 12n plus 1, which is 156 plus 1, which is 157. Right? And you notice I really didn't notice that. Look at that. All of that. I did not notice this. And if I had noticed that, all of these numbers is just 1 more than that. If I had noticed that, I would have arrived at the 12n plus 1 a lot quicker. Right? Because I would have said, well, it's just, if this is 12n, this is looking like just 12n plus 1. So it's easy to see. Yeah? So now I could figure out that this here will be 5 times n, no, sorry, 12n. 12n, so that's 12 times n is 5, right? 12 times 5 is 60, right? And so therefore this will be 61. And that's it for the sequences question. It's actually quite an easy question. It does require a certain way of thinking. So go to the video, and that video actually has hints and steps that you could use to figure out this question, right? Question 7. The number of dots in 2 consecutive figures are recorded. This information for the first 3 pairs of consecutive figures are shown in the table below. So the number of dots in 2 consecutive figures are recorded. So 13 plus 25. Alright, so 13 plus 25. And 25, so 13 plus 25, and then they take the 25 and they add it to the 37, and then the 37 and they add it to the 49. That is what they did. Alright, so determine the total number of dots in figure 7 and 8. So this is figure 3 and 4. So figure 3 and 4 here. So figure 7 and 8. Figure 5 is here. So I have to find for figure 7 and figure 8 for the number of dots. So the number of dots is 2n plus 1. Therefore, for figure 7, it would be 2 into 7 plus 1. 7 2s are 14 and 1 is 15. No, it's 12n, sorry. So I was wondering, right? So 12 times 7 is 84 plus 1 is 85. So this here is 85. And for figure 8 is 12, 8 plus 1. So 12 times 8 is 96 plus 1 is 97. Therefore, 85 plus 97. So, seeing that I didn't really do this topic in detail with you guys yet, and I left a video there for you, Scotia, how did you manage this topic, this question? It was good. You get through it all of the answers so far?
Yeah.
Alright, how about you, Shazay?
Yeah.
Alright, okay, good, right? So if you guys are okay with this topic, that is great. But please check out the video because it's only 20 minutes. And, you know, I do leave some hints and tricks as to how to do all of this stuff. Figure n and figure n plus 1. Ooh, that's nice. Right? So figure n will be 12n plus 1. Right? And then I added that to figure n plus 1. So figure n plus 1 will be 12n plus 1 plus 1. Right? So on this side I have 12n plus 1 plus, on this side I'll expand this out. So this will be 12n plus 12 plus 1. So that will give us 12n plus 12n is 24n. And now I have 12 plus 1 is 13 plus 1 is 14. So 24n plus 14. Section 2. I wonder if we could finish by 8 boy. Solve the pair of simultaneous equations. Well, you can see here that we are going to end up with a quadratic. Right? So you could expect to end up with a quadratic with that square over there. They already gave us, and I'll just put this as 2 and this is 1, and I'm going to sub 2 in 1 because they give us a pretty easy thing there. X is equal to that. So it implies, and notice the statements that I'm making, right? Y squared plus 2y plus 11 is equal to x, which is 5 minus 3y. So now it's just a matter of doing thing, right? I'll throw the 11. Well, I wouldn't throw the 11 across because remember, to factorize it, I'll need to have everything equal to 0. So I'll bring everything across, right? So I'll get 5, so y squared plus 2y plus 11. I'll bring the 5 across to get negative 5. I'll bring the 3y across to get positive 3y. And on this side, I'll just have 0. Okay? So now I'll have y squared. I have 2y plus 3y. So that gives me 5y. And now I have 11 minus 5, which is 6 plus 6. Okay? And now I have to factorize this in order to get the values for y. So to factorize, I could see that the value of a is 1, so I don't have to worry about that grouping thing. I could just factorize. So I need two numbers that when you add them, you'll get 5, and when you multiply them, you'll get 6. And that should be pretty easy. The numbers are 3 and 2. So y plus 3 and y plus 2, because everything is added. So you can see here that 3y and 2y will give you 5y, and 3 times 2 is positive 6. And that is equal to 0. Therefore, y is equal to negative 3, or y is equal to negative 2. Yeah? So solve the pair of simultaneous equations. So you can see here I have two values for y, right? So now sub in equation 2. And what is equation 2? X is equal to 5 minus 3y. So when y is negative 3 implies that x is 5 minus 3 into negative 3. X is 5 plus 3 3's are 9. 9 plus 5 is 14. Right? Therefore, y equals negative 3 and x equals 14. Right? And when y equals negative 2 implies that x is equal to 5 minus 3 into negative 2, which is 5 plus 3 2's are 6, which is 11. So therefore, when y equals negative 3, x equals 11. School, show how you guys did with this one.
Alright.
It was okay. Yeah, you made some mistakes, but you understand what I did?
Yeah.
Alright. Shizzy, you understand what I did here?
Yes.
Alright. The function f is defined as that quadratic equation here. Express f of x is of the term that. This is completing the square. Okay? When it comes to completing the square, it essentially have two formulas that I want you to remember. The first formula, just remember, and you should have this on your cheat sheet. The first formula is h, recall, and I'll do it one time. I'll write it as part of the solution. Recall h is equal to b over 2a, and k is equal to 4ac minus b squared all over 4a. Right? Notice the statements that I'm making. I'm recalling these things first so that I could get them out of my brain and onto the paper. So now that they are onto the paper, I don't have to look in my brain anymore to remember them. Right? They're on the paper now, right? Where, remember, this is A, this is B, and this is C. Yeah? So I'll just make a note of that. A is 4, B is negative 8, C is negative 2. So once you remember these two formulas, and trust me, it have many other ways to figure out the completing the square. You can actually do it with a diagram too, but trust me, once you know these two formulas, you'll just save a lot of time, right? So therefore, h is equal to b, which is -8, all over 2a, so 2 times 4, right, which is -8 all over 4 2s are 8, so therefore h is -1. K now is 4a, which is 4, times c, which is -2, right, minus b squared. So b is -8 squared all over 4 times a, which is 4, right? So what do we get here? Well, 4 4s are 16. 16 times -2 is -32 here, right? Minus this -8 squared will end up being a positive 64, right? So this positive 64 is in the brackets there, is where I squared -8, but still have this minus sign, so you have to be real careful about that, right? Divided by 4 4s are 16. So what do I have here? I have, when the signs are the same, you add them. 32 plus 64 is 96, and you keep the sign, -96 divided by 16. And then we have the answer of -6 here. So we see here that h is -1, k is -6. So therefore, f of x is equal to a, which is 4, open brackets, x plus h, so that is x minus 1, close brackets, all squared, plus k, which is -6, is of the form a x plus h squared plus k. So whenever you're dealing with these, once you see this is completing the square, and you have to know these two formulas. Trust me, please learn these two formulas by heart. They are not in your sheet, right? Also, there are also other things that we have to remember about these formulas as well. Remember, and just as a little review, the quadratic equation, when a is positive, that means that the graph is going to look like this. Positive gives you a smile, negative gives you a frown. So we can see here that a is positive, so that means that this graph is going to look like this, right? And whenever you want to find the minimum point here, this minimum point is the line of symmetry, and that line is x is equal to -h, where the minimum point over here is -hk. So it is important to just remember all of these things. And of course, everything is in the Google Classroom, right? State the minimum value of f of x. Well, look at that, right? The minimum value. So you're supposed to know what that means. At the end of the day, this quadratic equation, a is positive, so it's going to be a minimum, right? And just now, let me just check one thing. Let me just make sure. Yes, okay, right? So it's going to be a minimum, and so therefore the minimum value implies the coordinate minus hk, right? So that means h is -1, so that means that minus h and k is -6. So that means that it's the point 1, 6, -6. So the point 1, -6, when this thing drops so, right, it dropping at 1 on the x-axis and -6 on the y-axis there. right? So these are things, and I'm glad that we did this question because I'm sure that you guys, well, I hope that you did remember it. I'm kind of guessing that you didn't remember these little formulas here. And once you know these little formulas, you should be able to tackle anything. Determine the equation of the axis of symmetry. So that's another 1 mark. Remember, the axis of symmetry is this line here, and that is the line that will be the x value, and the x value is minus h. Yeah, so it is the line x is equal to whatever minus h is. So therefore x is equal to negative h. So therefore it is the line x is equal to negative 1. That's what h is. So it is the line x is equal to positive 1 that we could see here, because, you know. Right. So Scotia, how you felt about this question?
Good.
Oh, you did it correct? You get it through?
Yeah.
You did you got these formulas, aren't they?
Mm-hmm.
Lovely, beautiful. Thank you very much. I'm quite pleased, right? The speed time graph below shows, and I'm really tired right now, guys. Ollie wouldn't believe how hard I worked for Ollie today. Eh? Right now, I just super tired. And my mouth dry, and I don't have anything to drink, right? How much questions we have again, boy? 9. And 10. Wow. Quite. Not too much, but it'll still take a while. I doubt we'll finish by 8 o'clock, right? Alright. So we have here the speed time graph below. Not drawn to scale, shows the 3 stages of a journey of a car over a period of 40 seconds. So we see 0 for 40, the time and the speed in meters per second. So it gets as fast as 12 meters per second here, right? Determine the acceleration of the car for each of the stages of the journey, right? So for stage 2, we can see here, for stage 2, it's this stage here. And the acceleration for stage 2, well, we could see here that it goes from 16 to 32. So 32 minus 16 is 16. So this is 16 seconds it spends here. But you know, it goes from 12 meters per second to 12 meters per second. So at the end of the day, there is no vertical rise. There is a horizontal shift of 16, but there is no vertical rise, 0. So if we want the acceleration, we want the vertical rise over the horizontal shift. So we have 0 acceleration here, meters per second squared is the acceleration. And at the end of the day, we could see that it maintains the same constant speed. So we didn't really have to show any kind of working. We could see here that the acceleration is 0, right? For stage 3 now, for stage 3 we will have the vertical rise, which is 12, all over the horizontal shift, which is the horizontal shift 12 here, all over 40 minus 32 is 8. So 12 divided by 8 is 1.5. But it'll actually be negative 1.5 because the car is slowing down. It's going from 12 to 0. So the car is slowing down. So car is decelerating. I think decelerating only have one L though, right? So therefore, negative 1.5 meters per second squared, right? So circle theory. And you know I had to take a break before circle theory, right? The circle shown below has a center O and the points A, B, C, D lying on the circumference. So I see in the center O. Notice how I'm not reading the whole question, I'm reading it in pieces. A, B, C, D. I see in that, right? The straight line passes through the points A and B. I see in the straight line here. Right? An angle CBD is 49 degrees. I see in that. An angle OAB is 37. OAB is 37. Write down the mathematical names of the straight lines BC and OA. So BC here and OA here. So BC is a chord, right? And OA is a radius. Easy enough. Determine the value of each of the following angles. Show detailed working when necessary and give reason to support your answer. So you can see they even have a place for the reason here. Right? So they want X and Y. So let's see what's going on with this. We could see that X is the angle at the center. Right? And Y is this. Now Y is subtended by this chord here, BC. Right? And X isn't really subtended by a chord at all. It's subtended by the diameter. Or X is subtended by this chord BA. So, right? So X is subtended by the chord BA, going this way and this way. Anybody have any ideas what you guys did for this? Shazay, use the circle theory guy. Sorry? For what? And why? How you get 106? You take the 2 radii. Beautiful. Thank you very much. Yes. Alright, so good job. So OA is a radius and OB is a radius. So if OA is a radius and OB is a radius, then we could write here OA and OB. OA equals OB, which is radii. Therefore, OAB is isosceles. Right? Hence, the angle A, the angle B, let's just call it the angle B, is also 37 degrees. Hence, angle B is 37 degrees. Therefore, X is equal to 180 minus 37 plus 37. So 37 plus 37 is 74. 180 minus 74. Thank you very much, Shazzy, for saving me the brain work there. 6 degrees. Yes, because my brain is literally squishy right now after 12 hours of hard work, right? So definitely 106 degrees there, and that is pretty okay. And now that we have 106 degrees there, we can start to talk about Y. And let's see what's going on with Y. Y is subtended by BC, so it's subtended by that. Shazay, help with Y?
I think angle C is supposed to be a 90-degree angle.
How? Oh yes, because
Subtended by a semicircle 90 degrees.
very good. So this angle here is 90 degrees because it is subtended by the semicircle there. So very good, Shazzy. Excellent, man, with the circle theory there. So angle C is 90 degrees because it's subtended by a semicircle. So
Y is 41 degrees.
right, so angle C is 90 degrees because subtended by a semicircle. Semicircle. So therefore, angle Y will be equal to 180 minus 90 plus, what was the other one?
49 degrees.
40 what?
49 degrees.
49. Alright, so that is 90 plus 49. 139, 180 minus 139 is indeed 41 degrees. That's what you got, 41?
Yes, sir.
Alright, nice. Cool, sure. You did anything with this? But did you understand what we did? Right? So you could see here, first of all, for x, that this is a radius and this is a radius. Means that these two are equal. So we have an isosceles triangle. That means that this is going to be 37. And once these two are 37, we could do the whole triangle thing, right? Another thing, and good job, Shazzy, I really have to say great job there, is that we have a diameter, and the diameter subtends this angle C, so that means that that is 90 degrees. Any angle subtended by a diameter or a semicircle is 90. And so we could find Y from there using the triangle rule, right? Bearings. So we have the sine and cosine law that we're going to have to employ here now, because bearings is sine and cosine rule, right? So the diagram below, not drawn to scale, shows the route of a ship cruising from Palm City. I don't really care about what you name it, from P to Q and then to R, right? So what they're saying is that the ship's starting from P, and you notice how the bearing is always measured to the north line. So if it's going in this direction, the bearing is 133 degrees from the north line. So it's going from P to Q here. Yeah, and then from Q to R, the bearing is measured from the north line. So if it's going in this direction, the bearing is actually from this north line coming all the way around here. That is the actual bearing in this case here, from the north line going clockwise, going all the way around here. And that's how you have to measure the bearing of R, to go from P to R, right? So calculate the angle of W. Now remember, this is a north line and this is a north line, so these two are parallel, and so you could treat this like a transversal. So if this is a transversal, that means that this 133 degrees is actually going to be equal to this angle here. Yeah, so we could say here that 133 is equal to 56 plus W. Therefore, and if we have to give a reason why, alternate angles, right? So alternate angles is the reason. Alternate angles. Right? So now we can see that W is equal to 133 minus 56. It's 77 degrees. Right? So you know, even though yes, the north line is imaginary, but the north line is what we are measuring against, and the north lines will always be parallel. So we could treat it like a parallel. And you know, when we have parallel and a transversal, this angle is equal to this angle. Right? So this is the transversal, and this is the parallel lines here. And this is the transversal here. So this angle is equal to this one. Nice. We might finish earlier than I thought. Right? Determine the bearing of P from Q. So determine the bearing of P from Q. So that means that if I wanted to go here from Q and I'm going back along this line to P, the bearing from the north line is this. Yeah? So we could see here that the bearing is going to be this 133 plus this 180 degrees on this side here. So the bearing from P to Q, no, so the bearing of P from Q will be 133 degrees plus the 180 degrees, which is 313 degrees. The bearing, determine the bearing of P from Q. Yeah, so you're going from Q to P, so that is it. Nice. Now calculate the distance RP. So calculating the distance R to P. Alright, so I want to calculate this distance here, and I have these distances here. I also have this angle in the middle here. So how do I calculate that? Anybody? Scotia? What is the cosine rule? B squared plus C squared minus 2BC cos of the angle A, right?
Yeah.
Right. Now, we know that the angle, this is the angle A, and the side A is opposite it, and yeah, so therefore B and C are going to be the other two sides here. So that is precisely correct. So A squared now, which is RP, right, is going to be B squared. Well, we could call any one of these B. Let's call the 210B plus the 290 we'll call C minus 2 by 210 by 290 by the cos of 56. Alright, so A squared is equal to 210 squared. Oh, big numbers. 4, 100. We have to be very careful. Plus 290 squared is 100. Minus, let me just work out this entire thing, right? The cos of 56 is that times 2 times 210 times 290. Whoa, that's a huge number there. I got 68109.696. Yeah. So So a squared is equal to 44100 plus 84100 minus 68109.696, and I got 60,090.304. And now A is the square root of 60,000. So the square root of that answer is, what do you get for the answer? Push?
Yeah, I don't think my answer's correct.
Tell me.
Well, I got 44.7354.
Right. So I don't know what you did wrong here. The answer I got was 245.13. Right? Did you understand how I used the cosine rule?
Yeah.
What do you think was? Is it that you went from here and just punch in everything and jump straight to here?
No.
Did you go through each step and write out each number?
Yeah.
And which one of these numbers you get wrong then?
I think like when it came to the cost of 56 and stuff, I think that's where I went wrong.
Because you didn't get this value here.
No.
All right. Now, at the end of the day, remember you want to kind of look at it and use a little bit of reasoning, right? Because this is 290, this is 210, so this definitely looks like it'll be around 200 and something. Yeah. So you can definitely see that this is not going to be 45 or 44 or so, because 44 might be like that. You know, that distance, right? So so you really have to look at your answer and use some reasoning to see that all of these three lines look variably around the same length. We could see this 290 is very similar to this 210. So you would expect to get an answer somewhere in the 200s, maybe even the 300s, the early 300s, but somewhere around there, right? So be real careful when you are using your calculator, especially. Yeah, when I was punching this in, what I did was I punched in the cos of 56 first. Yeah, so the cos of 56 is 0.55919 blah 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 blah. I didn't round it off. I just took whatever that is and I multiply it by 2, multiply by 210, multiply by 290, and I got that answer there, 68,109, right? So be real careful how you're using your stuff, right? So that there was a, oh, let me just put that over here. Oops, that's not good. Come on, man, I want to go home, yo. One more question, 10 minutes. So it looked like we are going to be here until about 20 past. Nice. Vectors now. PQRS is a parallelogram. So thank you for telling me that, in which PQ is equal to U and PS is V. So if PQ is U and it's a parallelogram, that means that this is also U. That means that this in this direction is also V, right? Write in terms of U and V an expression for QS. So QS means that I'm going from Q to S. And if I'm going from Q to S, I could drive down here, which is minus U, because going up is plus U. So I'll have to drive down, which is minus u, and then drive this side, which is plus v. So therefore q to s is equal to minus u plus v, or v minus u. You can see here, if you take this road, you'll get plus v minus u as well. You can take either road to get there, right? You got this for that, Scotia? All right, lovely, right? QM. So QM, that's interesting. Did they give us anything about? Oh yes, look, they did tell us here, and I didn't even read it, right? M is a point on QS such that QM to MS is 1 to 2. So QM is 1 and MS is 2. So that means that I have a next one and a next one here. So that means that the full thing is 3. Yeah, so QM is 1/3 of QS. So I can make that statement one time. QM is 1/3 of QS. Right? So that is 1/3 of, what is? V minus u. And we could actually leave it like this. If you want to expand a third v minus a third u, you could do that, but it's actually more polite, and this is actually the simpler way of having it here, right? And final 2 questions of the day. Show that MR is a third u plus 2v. So MR So notice the sign M to R, right? Notice the direction M to R. So if I want to go M to R, I could drive M to Q, because I know what QM is, and then I could go Q to R, so that is V. QM is a third v minus u. So this QM, remember QM is going in this direction. That's a third v minus u. So therefore MQ is going to be minus that, a minus a third v minus u. Right? So I'll have MQ, just now, what do we want to find? MR? We want to find MR, and that we could say is MQ. And yes, you could have come in this direction too. You could have go MS plus SR, but we already know what QM is, so I'll just go MQ plus QR. MQ plus QR. So MQ will be the reverse of QM, so that is minus, and whatever QM is. QM is a third into v minus u, and then plus that v over there, right? So now I'll probably have to do the expansion. So I have the minus out there into a third v minus a third u plus v. So now I'll have minus a third v plus a third u plus v. And so now that will give us v minus a third. 1 minus a third is 2/3 v plus 1/3 u. Is that it? A third u plus 2v. Yeah, okay, we're almost there. Right, so we can see here how we found MR is MQ plus QR. So MQ is a negative in front of the QM, right? Plus V. When we worked it out, we got 2/3 V plus 1/3 U. We could see that we have 1/3, right? In common, so we could actually pull the 1/3 out. And what will we get? We will get 2V plus U. Alright, so 1/3 times 2v is 2/3v. 1/3 times u is 1/3 u. So therefore, 1/3 u plus 2v is the proof. You get through with that one, Scotia?
No.
Okay, but you understand what I did here?
Yeah.
You sure? Right?
Yeah.
I decided to use what I already had. I could have used ms plus sr, but I didn't know what ms was, and I would have had to find ms. However, if we did it that way, and if you did it correctly, you would have gotten the same answer as well, right? Once you do it correctly, right? T is the midpoint of PQ. Prove that R, M, and T are collinear. So T, let me rub off all of this. T is the midpoint of PQ. So that is T. And what they're saying is T, M, and R are collinear. So in order to show that they are collinear, right, I have to show that MR is parallel to MT. And if MR is parallel to MT and they both share the same point, well then they have to be on the same line. Then they are collinear, right? So I already have MR. MR is what? MR is that, 1/3 u plus 2v. So MR is equal to 1/3 u plus 2v, right? And let's see if we can make sense of that. So now we have to find, if this is t, we'll need to find mt and show that they are scalar multiples of each other. Alright? We could even find tm really. But mt would have been mq plus this. So we saw mq to be, what was mq? Minus all of that business. Alright, you know what? Instead of doing that, let's do it the easier way. Instead of finding mt, let's find tm. So if we have in tm, well then this will be easier because we're going in this direction, so that will be positive 1/2 u plus this direction, which will be positive qm, right? So I don't even need mr. Alright, so let's find tm, and in order to find tm, what did we say? We said it was tq plus qm. tq plus qm. So tq was 1/2 u because t is in the midpoint, plus qm, which we already found up here to be 1/3 v minus u. 1/3 v minus u. Right? Remember, we want to show that this and this are scalar multiples of each other. So let's work it out, right? So this is going to be 1/2 u plus 1/3 v minus 1/3 u. So where's 1/2 minus 1/3? 1/2 minus 1/3 is equal to 1/6, right? So 1/6 u plus 1/3 v. Can we factorize this anyhow? If I was to pull out 1/3, if I was to pull out a third, I would have to have a half u. So this times this would give me 1/6 plus v. So yeah, that pretty much almost looks like it there. We almost done there. So that means that if we look at the two of them, MR is 1/3 into U plus 2V, right? And now we have here TM, which is also a third, but the vector inside here is slightly different, plus 2V. Right? Look at the vector inside of here. What do you notice? No, not 2V, V. Look at the vector inside of here. What do you notice? If I take this one and I multiply it by 2, I will get this one. And you seeing that? Right? If I take a half u plus v and I multiply that by 2, I will get u plus 2v. Right? So you can see here that they are scalar multiples of each other. So now you can make the statement, well, if I take 1/2 u plus v multiplied by 2 gives me u plus 2v, and of course the third are the same, but that is no problem if the third is the same. So this implies that MR and TM are scalar multiples, and therefore R, M, and T are collinear. I guess that's the British way of spelling. Nice. Scotia, how do you feel about this one? It's a lot. Well, it is, you need me to explain over anything? I know your brain probably saturated right now, right? Yeah. So I'll see if I could get this video up by tomorrow. I wanted to get it up by tonight, but I really don't think I'll have the energy to edit this now. So I'll see if I can edit it by tomorrow and get this video up by tomorrow. But does anybody want me to explain anything again in this here? Scotia, you catch a drift of what I did here, right?
Yeah.
You're saying here. But in other words, what I did was, in order to prove that these three are collinear, right? And look, we already had MR here, so we already have the vector for MR. We already have this vector here, MR. So all I needed to do was find this vector TM. Yeah? And once I find the vector TM, which was a half U plus this QM here. And QM, well, we found QM to be this. So once I found the vector a half U plus QM and I did the algebra, I got this. And I want to see if this is some scalar multiple of this. And yes, it is, even though they both have the third outside. Yes, but if I was to take this one and multiply it by 2, I don't have to multiply the 2 by a third. I could throw the 2 inside and multiply it out. So therefore, TM, MR is equal to 2 times TM. Right? So we can see here that they both have the third on the outside, and it's just this little thing here, and the only difference between them is multiplying by 2. So it is a scalar multiple. MR is 2 times TM, and so collinear, right?